Welcome back to this video, everybody. As you know, I do like drawing and designing stuff, but if you want to build it as well, you need to know a little bit more about technical drawing and maybe also engineering drawing. So I thought in this video, I might delve a little bit deeper into what technical drawing is, and then we can lay it out to guys. So let's dive into this video and have a little bit of fun learning about engineering drawing. Alright, before we jump into it, we talked last time about this drawing that I tried to fix it. Still not fixed, but no problem. So why do we need technical drawing? I do this nice drawing, and even if it's, now let's not talk about the mechanical feasibility, but for somebody to build this, they need to have several angles. That's why here I also drew side views as well. So it's important to be able to get all the information through as few drawings as possible. So let's talk about technical drawing, because that's what an engineer or a person who's a builder needs. What is technical drawing? Basically, it's the orthogonal drawing, or orthogonal, I think it's pronounced. So we need the orthogonal view. So that is sort of what many people know under three-point perspective, but there is no perspective in it because all the lines are perfectly parallel. So if I draw a box like this, there we go. If we remember from math, arithmetics, geometry, I'm not sure which it was, but we have this sign that this is parallel with this, is parallel with this, is parallel with that. Then this is parallel with this one, and that one. And this with this one, and this one. So this means these will never meet anywhere. And we need these because we also need to do nice projection. This is the orthogonal projection. So what that means, if I have a cylinder that I'm going to draw now. So here we have our cylinder, right? If I put this into, well, let me always, I should draw the bottom first. I'll put it into this box. And let's say the cylinder is also parallel with the lines of the box. Then if I'm trying to project this from the outside, we will see this sort of rectangle here on the top. If we project it onto the top, we will see this rectangle, and here on the side we will see this circle. Okay, to explain this a little bit better, like imagine it if it's like a box, and like I'm gonna take this little device thing, whatever, I don't know what it is, I just found it, but I put this into, I'll make a box out of this, and here we will have a top, front, and a side view. Well, let me rotate it a little bit more so the side view is visible from here. So top, front, side. And if I open it, like how does this project here, here, and there? So let me look at the shape. I'm gonna take my pencil. I'm gonna say if this is the front, right? This is the top, and this is the side. Let me take a darker pencil so you guys see it better. So we sort, I'm just gonna draw it very roughly, right? So we know that this is the front, if it sits in there. So I'm gonna draw this very quickly there. Let me not jump over things, so it's not too fast for you guys. Then if we look at the top, let me put it back into its box. So what do we see from the top? We sort of see this line with the connection lines there. So means I see, and this is also where you use this sort of projection, because we know exactly how long it has to be, or how wide in this case. And you can also use some of these lines and just project them over there, because you know that these will come here. So we have a line here, there, and then we also have a line in the middle. There we go. And yeah, here we have these holes that I didn't really draw correctly, but I'm just gonna draw them in there. So we have the side, and then if we look at it from the side, right? So from here, what do we see? Well, we sort of, again, only see like a block. But the good thing is, so we can again project to the side. We know exactly how high it is from here, just drawing the lines. And then we can do the same again. Here we have, whenever you have a change in direction of the surface, you have a line. So this is all we see from the side. So now if I package this back up again, I can put this also back into the box, just as it was. Now we see perfectly, this is the front, this is the side, and this is what you see on the top. And then you unpackage it and you have this. And that's also what I was trying to do with some of the drawings in my desk sketch. Now, if you would work this out a little bit more professionally, which I did, you can see this drawing here. So it's basically the same thing as you can see. So we have the front view here, then we have the top projection, and I use these lines to nicely follow and correctly project. And because, so one thing is also important in technical drawing, because these have most of the information I have, I don't need the side view. But one thing that I need, because as you can see, there's like an indent here and an indent there, and they're also not the same distance. What I decided to do is to do a cross section down the middle. So if you think, if you would take something and just cut through the middle like this, and then you look from the side. So basically that's what we have here. And there are some sort, there are rules, there's a lot of things that you can learn, but I just want you to know the basics. So if you want to explain a drawing to somebody who's more of an engineer, like these are the right ways to go about. Some of the basic rules is obviously you need to, let me erase this, it was a little bit in the way. So if we want to give some dimensions, like this would be the length, and this would be the height. What you try to do is put as many dimensions onto one drawing as possible, but obviously the depth, I think, or thickness has to come up here. Important thing is not to over constrain when you want to do dimensions. So if you know, let me see, I wrote these down somewhere. So this is 31 millimeters. And if this is, I think it was 28 millimeters, you don't need to give the dimensions of this one as well, because we know 31 minus 28 is 3. So we know that this is going to be 3 millimeters thick. So that would be over constraining. I would say you could do something like here, because we need to know how thick this is. And this is 2 millimeters, and this is 5 millimeters. And usually it's understandable that this is 2 as well, but you can just make sure. In this case, I would say you can give a 2 millimeter here as well, because we have sort of discrepancy. And here, this is 2 millimeter as well. 2 millimeter. Anyways, I don't want to go too much into details with this one. Let me jump a little bit into my drawing with the table. So for this visual, if I would want to make a technical drawing of this is a start, of course, and I'm not going to make a super technical drawing because you need a nice setup and there's like specific layout and everything that you're using. But this already is an assembly drawing. And why is it an assembly drawing? Is because we have several parts that are connected and actually working with each other here. So we have this main frame that is shaped a little bit like this, if we follow this. Then we have, let me add actually a extra layer. We have this L shape here, and then we have this L shape here. These are connected with those pins. And then we have this wooden shape here that is probably connected with some sort of screws as well. And then we have this L wooden shape, this L wooden shape, and then we have this big wooden shape as well. So this is a lot of parts, and all of them need their separate drawings. So what I would say is that we draw this one apart and then maybe take a combination of these two as well, how we would put them together, just to do a little bit of explanation. Let's jump into it. And what I'm going to do, is I'm going to draw a pre-drawing with pencil very quickly. So one thing you can already see, I stop with the lines at some points. It's very important to know whenever you have a line, there is a change in surface shape. So that surface changes angle. Like even at the smallest angle shape or angle change, you need to indicate it with a line. And in this case, I also made a little bit of mistake, because if we look at this, so what I mean by that, if we look at this, this is the same surface, same as here, like this area. And I put in a line, I wanted to zoom in. I put in a line here, which means that there's a cutoff, which is not correct. So I do have to fix that right now, because otherwise, if somebody looks at this visual, they're going to be confused what that is. Okay, let me continue. Okay, so some information that we know already from here is, here, see, this, because we have this angle here, we will see this line, which comes here. So this angle here is represented here. And as you can see, because this in the background, this leg, gets cut off by these two lines. So we know from here that this is in the back. You can, if you're just doing sketching and not necessarily technical drawing, you can also add a little bit of cross-hatching, and then we know that that is further back. Now, we have some information here. We know that there's a dot. Like if you want to be precise, you could add sort of like almost like a plus, but it's like a cross. And that's an indicator that there's something that can rotate. Let me draw out the top view as well, though, because that will help us more. So these have to be visible again, of course. This is where our support ends. And this line has to be visible, and this line, and also this one and this one. As I say, it's a change in surface. And now, this one, so we would have this one here, and this one here. So this was our drawing previously. But since last time we talked about in the video, I added this extra line here, well not extra bar to help us with the structural stability of it. So I needed to cut into the surface here, which you can see it a little bit. Let me take away the red bar part. I did cut into the surface. So since this doesn't just hit this surface here, because there's a hole there as well, I need to draw this whole line. Otherwise, it will be confusing. So this is a hole. It's not clear yet, but it's going to be clear when I start drawing this one as well. So this is why we need the several views. Okay, and now we see that here we go through the material. So there's a hole there. This can be explained even better. I mean, at least it is a bit hard, but if you want to dimension it and everything, what you have to do here is to do a cross section. And for a cross section, I'm just going to do two thicker lines here and then thinner dashed lines there. And I'm going to say arrow, arrow to both these lines. And I'm going to explain this in cross section AA, which is going to be AA right here. So what I need to draw is sort of, because we're looking again from the front, so from here, but we're going to have a cross section. So I'm going to make sort of like a circle, which is not necessary, but let me just do my thing. And then this is our leg. And this is our support here, which means this is the hinge area. And then this is the other support bar or beam right there. And then from here, it is thinner. And then the hole, here I can make it then bigger as well, means would be somewhere here to here. Okay, so a lot of stuff. If you add nice cross hatches like this, it shows you that there you cut into the material. So there we actually are looking into the inside of the material. So now if we have an AA view here, this shows us that this whole area here doesn't cut into the material because it is empty. So this is the upper part here we cut into, and the lower part here we cut into, but we know that here we have a nice empty area. So this is one part, but I said, okay, let us talk a little bit about these two elements as well. All right, so let me talk about that L shape. Okay, a little trick here. So I said before, when we have this sort of cross, this signifies that there's an axis that you can rotate around. It's the same thing with this. So when you're looking not straight like that, but from above, this shows us the axis. One thing that we need more is we're also going to have the same thing with a piece of wood. So this is the iron bar and this is the wood. Now, how are these two put together? Because right now, like in the drawing, if we look at this, it's just magically glued together. That obviously doesn't work. So what I was thinking as a quick solution, what if we, so let me draw it out separately here. So if we put them together already, so this is the metal part and this is the wooden part. What if we put sort of a screw into the metal and then just jam the wooden part in there? So that means if we look at this area, I'm going to take the pencil again. I'm going to need an area. So this is where the screw goes in. And there's a specific way how to draw a thread. And I'm not going to lie to you, I don't remember it exactly. I think it was something like this, if I'm correct. Because first, you drill a hole, and then that would look something like this. And then you go in with a thread cutter, and you go up until there because you can't go to the end, and then that is the thread. And then once again here, you have the hole, which looks like this, and then with the thread cutter, you go up until there. And this is only visible if we did sort of a mini cross section here, which means that I have to do this cross hatching and show that that is actually cut into the material itself. And in this case, this front view doesn't really help us. But for these, I'm going to put a couple of links in the description. There's a lot of information how to draw this correctly. I don't want to go too deeply into it. I don't want to make it too boring. But this is important because then you can say, I want the distance here to be X and the distance here to be Y. Or actually, you can give that there as well. What's important here is for you to know like this distance. But usually it's centered. So that's fine there as well. And then you can do the same thing with the wood here as well. So let's say if it's going to have the hole here and it's going to have the hole here. What I would do here, because obviously we can't screw it into both at the same time, especially if you have two screws. So this would be the screwing in part, and here I would make it a bit maybe tapered. So I would say I have this and I have this, and then I make sure to explain that we have I don't know, a 0.5 degree taper there, like that. You can also show that this is a cylinder by giving this, and then you have to make sure that you explain that this is within the wooden part. Let me finish up this video with a 3D view of the assembly between the metal part and the wooden part, and obviously the connecting rods in between, and I'll make it a little bit see-through so it's also more understandable what I'm going for. But yeah, so the whole takeaway of this video is for you guys to understand a little bit what the value in technical drawing is, and especially if you are makers and you want to design your own stuff, that you also think about maybe having it built. this sort of technical or engineering drawing really helps you in communicating with the people who will be able to tell you if something is feasible or if it is not feasible. Once again, this was a very superficial approach to the whole technical drawing. There's a lot of learning that you can do, and there's a lot of rules that you have to know, but I left a couple of links in the description box down below that you can check out, and hopefully they will help you. And you can also leave question if you are interested in more. As always, if you liked this video, hit that like button. If you didn't, hit that dislike button and also tell me why you didn't like it. You can subscribe if you want more content like this, but also probably more drawing related content than this. And as always, I want to wish you guys a great week and see you in the next video. Bye bye.